by Ian from WorldCoin. And as usual, please, if you have any questions, just let me know so I can bring the microphone to you. And yeah, that's it. Thank you.
All right. Hi, everyone. I'm Ian. I do developer relations for the WorldCoin project, specifically working for Tools for Humanity. And in this workshop, I will go over what World ID is, why WorldCoin created it, what you can do with World ID, and most importantly, how to integrate World ID into your project. So, World ID is our global proof of personhood protocol that allows you to prove that you're a real human doing an action only once without revealing to anybody, not even to WorldCoin, which unique human you are. Right. This is a really big, important question that we're answering. Bots have gotten out of hand and will only continue to get worse. Sybil resistance is a huge problem in this space. And basically any project benefits from knowing that that user's a real human and that they only have one account. World ID is built to be private, inclusive, and robust, right? All we want to know is that you're a human. We don't really need to know which human you are. As many people as possible need to have access to World ID, and we want it to be robust, ensuring that it really is just one verified World ID per real human. We looked at a lot of different ways to go about solving this problem, but an email or phone, it's easy to get multiple of those. We looked at doing KYC of government IDs, but less than half of the global population has a digitally verifiable government ID. Webs of trust work well at smaller scales, but scaling them to all of humanity is a really tough problem when your initial trusted set is only a couple hundred or a couple thousand people. But biometrics can do a really good job of proving that you're a human and proving uniqueness. When it comes to biometrics, there are lots of different types of biometric markers we can use. We looked at fingerprints, face scans, palm scans, but those can change over time. They don't scale super well to all of humanity, right? Face ID and Touch ID on your phone can distinguish about 1 in 30 million people. That works fine for one-to-one authentication, but doesn't do super well when you're trying to prove that you're different from millions or billions of other people. DNA, very, very unique, but it also isn't private. It tells us a lot about who you are, and that's not information we want. So we settled on using the iris. Lots of uniqueness, does not change very much over time, and another benefit of it is that it's something that's really hard to do passively, right? You can't just snap a photo as someone's walking by. They have to choose to look into the device that we use, the orb, which you'll see in a second. And if they don't want to get signed up, they can close their eyes, look away, which is good. Consent is an important part of any system involving biometrics. So when it comes to how we actually interact with biometrics, we looked at phone sensors, but the cameras just aren't high enough quality, and it's somewhat difficult to trust that that device hasn't been tampered with in any way. Off-the-shelf hardware is better in terms of trust, but it's usually not very portable. It can be expensive. So we settled on building custom hardware. And that is the orb, which you've probably seen at our booth, seen at locations around the world. And the orb has been in development since late 2019 and gone through lots of different revisions to get to where we are now. And the orb has a really important job. It checks to make sure that you're a real human, not a cat, not a dog, not someone holding up a photo of a human. On the device, it calculates an iris code, a digital representation of the pattern of your iris, so that we can use that to prove that you're unique without having to store the images of the iris. By default, the images taken by the orb are simply processed in memory and then deleted and don't need to be stored at all. And then, once we have verified that that iris code hasn't been signed up at the orb before, it verifies your World ID. World ID as a whole is built to be privacy first, decentralized, and open source. Any information that we don't need to know in order to prove that you're a unique human, we don't want to collect, don't want to store. It's designed to be decentralized, and we have a wonderful blog post that can go more in depth about that. And it's open source. Everything relating to the protocol is already open source on GitHub. All of the smart contracts, the sign-up sequencer, all of our dev tools, And then the Orb hardware is open source. The Orb software will be open source later this year. We want to be fully open about it. There's lots of different use cases for World ID. Voting is a great example. You want to know that each real person only gets to do a single vote. Social media, it's great to know that that account doesn't belong to a bot. Customer incentives is one I find particularly interesting. I have made a lot of emails to sign up for a lot of Netflix free trials, but World ID can prevent that. And World ID is also super easy to integrate. You can use it on the web, you can use it on mobile, you can use it on chain. And there's two main ways to integrate World ID. Sign in with World ID. Our OpenID Connect provider works just like sign in with Google or sign in with Facebook. And then we have incognito actions, which are much more powerful and what you can use for on-chain applications as well. So I'll start by going through sign in with World ID, and let's see how it works. So here, I'll go ahead and sign in to our developer portal at developer.worldcoin.org. And I use World ID to sign in. So I'll hit login. I'll sign in with WorldCoin. And then from within World app, I'll scan this QR code. It'll load for a second. The Wi-Fi at hackathons is always a little bit worse than we want. There we go. So I can see that I'm signing into the WorldCoin developer portal. It's a verified application, and I'll tap Verify with World ID. And then I am signed into the developer portal. In the dev portal, I can create and manage applications and actions, everything like that. I'm happy to walk through that outside of the workshop because I want to get through some of the code. But signing with World ID is super, super simple to use. And there's lots of different ways you can integrate sign-in with World ID. You can use our Auth0 integration if you already have other sign-in methods with that provider. You can use Next.js. You can directly use some other OIDC library and use our OIDC well-known file to configure that easily. You can custom implement the OIDC flows. But I'll walk through how you can do it with Next.js, which is what our sign-in template repository uses. And really all you need to do is add this sign-in provider to Nextauth's configuration, and everything else related to sign-in gets handled automatically. All right, so we have this provider that we'll call WorldCoin and use WorldCoin as the ID. We configure that well-known file, which is part of the OpenID standard, and tells it, here's where you redeem an authorization code, and all of the technical details like that is part of the standard. We have to input the client ID and client secret that we get from our developer portal. We'll use the ID token flow, and then we'll map information to the user's profile. So the profile.sub, that is part of the ID token format. That will use the nullifier hash, the unique identifier of the user in the context of your application as the ID. And then for the verification level, that should be renamed to verification level here, that's my bad. That will tell if the user is Orb verified or device verified. Right? Orb is this gold standard for knowing that that's a real person who only has one account, but for users who may not be able to access an Orb, we also have the device credential, where the World ID wallet will verify that that is a real version of the app. It is a unique device with only one World ID associated with it. And it's a weaker credential in terms of proof of personhood and sybil resistance, but it still is a way the user can sign into your application, and your application can know which verification level that user has. So now that I've gone through sign in with World ID, I'll talk about incognito actions, which is what most of you will likely use in the hackathon. With incognito actions, you can know that your user's a unique human doing something only once or however many times you want. You can set that to be unlimited if you'd like. You can let someone do something just 3 times and with a specific signal. And that signal is a piece of extra information that you include with the World ID proof that can't be tampered with. So for voting, for example, that could be which person someone's voting for in an election. So you know that when the user verified with World ID and created that proof, they wanted to vote for this person. And when you're verifying that proof, you can ensure that the correct vote is actually counted. When using World ID, you'll use IDKit, our front-end widget, which will display a QR code the user scans that includes information about which application and action that user is verifying for. On the mobile device, a zero-knowledge proof will be generated and then returned to your app, and your app then verifies that proof either with our developer portal API for off-chain use cases or with our smart contracts on-chain. Right? And this is what that proof looks like. We have the root of the Merkle tree against which the proof is generated. On Ethereum mainnet, we have a Merkle tree that is essentially the list of world IDs that have been verified at the orb. The nullifier hash is the unique identifier of the user in the context of your action. The proof is a very long hexadecimal string that is the actual mathematical zero-knowledge proof, and then which verification level that user verified with. So let's see what incognito actions look like. So we'll use the try it out page on our docs as an example here. And we'll go with staging because we're going to use the simulator here. The simulator is what you use instead of World App for our staging environment. There's lots of different identities that you can test with. So if you want to test sybil resistance, it's sort of difficult if you only have one identity you can test with. But we'll go with staging. We have our test action, and we'll have a minimum verification level of orb verification. So I'll tap Continue with WorldCoin. This button can say whatever you'd like, but it opens up the widget here. And if I'm running the simulator on my phone, I can scan the QR code with the camera, just like I did in World App. But I can also just click the QR code to copy the information and paste it here in the simulator, just the same as scanning it. I'll go ahead and verify with the orb verification level. And then this queried our developer portal API to make sure that proof verified correctly, and we can see that it did. Now, let's say I want to try verifying again. We'll see that it won't verify because this person has already verified for this action. So any use of incognito actions will start with IDKit, and it's a single React component. You can also use it in vanilla JavaScript as well, and we have a separate package for that. But all you have to do is configure your app ID and action that you got from the developer portal. There's 2 callback functions. OnSuccess is required, and that's the function that gets called after the IDKit widget is closed. Handle verify is useful if you're doing off-chain proof verifications with our API, where you can verify that proof while the widget's open and display an error to the user in a pretty way, but handle verify is optional. And then you can set the required verification level. By default, that's set to orb, but if you set it to the device verification level, your app will accept proofs that are either from device verified or orb verified users. And then we have this child that is the button that opens that widget. So you can style that however you'd like, make the text whatever you'd like, but it just has to call open on the IDKit widget to cause it to open up. And this proof response that you saw earlier is the input to the onSuccess and handle verify callback functions. So we have that proof, but we have to verify it. And I cannot make that clear enough. You have to verify that proof. To verify that proof with your API, the first thing you should do is take that response object and pass it to your backend. You want to do this proof verification in a controlled context, because in the front end, the user could modify anything there. They could just trick your application into thinking that they are verified. In your backend, they don't have that sort of control. So all you have to do is make a single request to our developer portal API. So it'll be developer.worldcoin.org/API-v1 verify, and then your app ID. The request body will include the action, the signal if one was provided, and then all of the information from that proof response object. And then the response will be a 200 if the proof verifies and if the user hasn't already performed this action the maximum number of times. for API verification, you set that in the developer portal, however many times you want to let the user do that. And if the response is successful, then you should go ahead and do whatever action it is that you wanted to gate behind World ID, whether that's marking the user as verified in your database or whatever else. But if it's a 400 response, it will include an error code indicating why it didn't verify, and you shouldn't do anything except present that error to the user at that point because they're not verified with World ID. This one's, the API verification is quite simple, but now we'll get into the on-chain verification. So we have a template repository for the cloud verification as well as the on-chain verification. For the on-chain verification, I especially recommend using the template repository. But to start, in our constructor, there are 3 things that we need to set. World ID is the address of the World ID router. The address book in our documentation can get you the correct address based on which chain you're deploying on. And then the app ID and action ID, again, that you get from our developer portal. And in the constructor, we should compute this external nullifier. It's a combination of the app ID and action ID that's used specifically to just denote which action that user is performing universally. World ID as a protocol is based on semaphore. If any of you are familiar with that, you'll probably recognize that term. Just for us, having that app with actions within it makes it a bit easier to do multiple actions within one application and still display that application to the user in a pretty way in World App when they're verifying, so they know what they're verifying for. And then we'll have a function that can be, in this case, named verify and execute. You can name it whatever you like based on what the user is doing. So this should take in the signal, if you're using one, again, the root of the Merkle tree, the nullifier hash, and that proof that you get from IDKit. So the first thing we'll do is check if we've seen this nullifier hash before, right? So we have a mapping of the nullifier hashes, and in this case just to a Boolean value, where when we verify a proof for a specific nullifier hash, we'll set it as true so that we make sure this user can only do this action once. For on-chain verification, you do have to implement that sybil resistance in your smart contract yourself, in contrast to API verification where we handle that for you. But once we've checked and made sure the user hasn't done this action before, we will go ahead and call verify proof on the World ID router, and we'll pass that the root, the group ID, which is 1. That should be just a constant in your contract. That group ID determines which credential we're verifying for, but only the orb credential is supported on chain at this time. So you can hard code that to 1 if you'd like. And then input the signal. So we ABI encode it and hash it a specific way for the protocol. That hash to field function is defined in our smart contract template. We also have to input the nullifier hash, that external nullifier determining what action the user is performing, and the proof. And if that proof verifies, the contract will continue. But if that proof doesn't verify for whatever reason, it will simply revert at this point. So once that proof verifies, we should mark that nullifier hash as true. We've seen it before, prevent the user from performing this action again. And then at the very end of that, that's when you can perform the actual action your user wants to do, whether that is minting an NFT or whatever else. And that is a great overview on how to build with World ID. Worldcoin.org/London24 will take you to a Notion page with a bunch of resources for you. Our template repositories, documentation, developer portal, bounty info. And if you have any questions, I am happy to go ahead and take some now.
So the zero-knowledge proof, when you want to prove the action, is generated by your app when you are scanning the QR code. So my question is next. When you are using a third-party app, for example, an iPhone, can you somehow call the app of WorldCoin in order to generate this zero-knowledge proof of the action. So you can submit it on-chain from your app, not from the WorldCoin, and not from the front end on browser.
We will support that in the near future, but at this time you do have to use IDKit for generating that proof.
Is the code base of this IDKit so hard? Maybe we can try to port it to...
You're more than welcome to try. It is written entirely in TypeScript, but it is open source. I will encourage you to try, and I'm happy to help.
Yeah, another question. So let's say for the cases where you want to have a proof of personhood for your, let's say, social media or something, that one person can only create one account and protect this way from the bots. What do you do for the case when the person loses access to their account? Because normally they would go and create another account, but in this case they won't be able to create a new account because there is an action that can only be done once and it's already done. So how do you go about this issue?
That is a great question, and with that, I would say that typically you should, if you are using our sign-in provider, for example, you should encourage the user to set a second login method, such as email password, connecting a wallet, whatever that may be, so that if they were to lose access to their World ID, they can use that other method, and if they lose access to that other method, they can use their World ID. For something using IDKit, what you can do is set it to a higher number of times that you're allowed to perform that action, but make it so that that nullifier hash can only be associated with one account at any given time, right? So say it's an application where my wallet is my sign-in. I can associate my wallet address with my World ID nullifier hash in your application's database or on-chain. But if I go to verify a different wallet with that same World ID, it will just remove the associated nullifier hash from the first wallet.
Hi, thanks for the presentation. I have a question regarding anonymity, because you mentioned that WorldCoin could be used. One of the use cases is e-voting, right? And how do you disallow linking the person, the data that you get to the person, or two different actions, for example, two different votings by the same person?
So the whole point of how World ID is designed is that it is anonymous, right? So in voting, for example, if those votes are two different actions, which they should be, that nullifier hash, for me, if I vote with the same World ID on both of them, I would have a different nullifier hash, and the point is that you can't tell that those two votes came from the same person. It's better for privacy. As for that person's identity, right? We don't have information on that person's name, address, government ID number, anything like that. So this can work really, really well for something like DAO voting. And you can do one person, one vote. They have to connect a wallet, show that they are a member of the DAO, but preventing one holder who has a bunch of the token supply, for example, from being able to just outvote everybody else because they have so much of the token. And if any of you have any other questions in the future, you can come find me at WorldCoin's booth, and you can also ask in the Partner WorldCoin channel in Discord.